Platform engineering is the discipline of designing and building toolchains and workflows that enable self-service capabilities. This session will introduce you to platform engineering and how it is being adopted with cloud engineering practices. Our speaker is currently a cloud engineering manager at StratPoint. He co-manages StratPoint Cloud, focusing on engineering practices for professional and managed services, using different cloud technologies. Let's give a warm welcome to Mr. Kevin Ventura.
Hello, everyone, and let me just share my screen. All right, all right. So, welcome to our session entitled "Introduction to Platform Engineering," and I'm Kevin Ventura. I'm a cloud engineering manager in StratPoint Technologies, and I'm here to talk about platform engineering and how we can all utilize it in the IT industry, and especially in doing our day-to-day work, right? So for my agenda this afternoon, yeah, I want to start to de- to describe in what platform engineering is, and at the same time, DevOps and platform engineering. Maybe you wonder, is it DevOps? And I want to emphasize this key message this evening: platform is a product. As we start, let me share to you a story about GoDaddy. So when we went to AWS reInvent, I saw this talk in uh, in one of their sessions wherein GoDaddy actually shared this platform that they have internally, and they call it the Next GoDaddy Experience. So basically, this Next GoDaddy Experience platform that they have is their one-stop shop wherein software development teams can provision resources and go here when they needed infrastructure. So we all know GoDaddy, right? It's the service and that provides domain, website, and email marketing. They have thousands of users and millions of domains they're handling. And uh, when you see their architecture, they actually wanted to create the right level of abstraction for them to easily scale and create applications for their business. So just to show you what it looks like within them, right? So when you go to their platform, when you go to their uh, internal development platform. As you can see, there are predefined architectures already that their developers can select to, like an EKS setup, a serverless one, or maybe infrastructure uh, EC2 setups. Then in in the next step of their platform, when using it, you there's networking that is already predefined or pre-designed for them. They'll just need to select what kind of network do they need, VPN or connectivity on their cloud, on or their on-premise setup. And interestingly, they have this uh, integration with their support channel. So they already created the platform to be able to be connected to Slack. So what's the advantage? Why did they do it, right? So without automation, the way they create their cloud infrastructure, it 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 will uh, they needed more days and they needed to code everything for weeks. So instead of doing it in days and weeks with the right abstraction, with the right automation, it will just take them minutes and hours to actually provision, to actually create the infrastructure that they need, right? So, uh, Basically, if you don't use automation in your infrastructure, you're doing what you call click ops. You click the graphical user interface of the cloud provider that you are using instead of codifying everything and automating everything. Right? So, the question that I want us to all have and I want us to think about is what can you do to fast forward the overall developer experience on the project you're working with or on the company that you are connected with or overall the way you do things as a software development uh, team, right? So let me guide you through platform engineering. Platform engineering is the discipline of designing and building internal development platforms, toolchains, workflows that enable self-service capabilities for software engineering organization. There are three important pillars of platform engineering that I'm going to share: the practice, the people, and product. Practice, it's really about designing and building the right level of abstraction. It's not, uh, sometimes we focus so much on the technology or focus so much on the programming language or the latest uh, approach, but it really depends. Platform engineering is designing and building the right tools, combining the right tools, and creating that workflows to have that right level of abstraction. So engineers can have a self-service platform for their needs, right? So, what is a platform? In personal computing, a platform is a basic hardware or software on which software applications can be run. If we know iOS platform and Android platform, you can only run iOS apps on iOS, of course, Android apps on Android, and there are cross-platform technologies or tools in the mobile space like Flutter that you can run that you can use to build for both platforms, right? So generally speaking, in terms of what we do in infrastructure in DevOps, uh, our platform, our back-end services, it always run in the cloud. There's always a compute layer. Maybe on-premise, there's a uh, data center that where the applications are running. So generally, yeah, in the Web 2.0 uh, moments, right? Our applications run in cloud. So most of our applications run in our cloud. So I want to talk about the second pillar, which are the platform engineers. What are they actually doing? So platform engineers build the integral product. So they're the ones developing the uh, internal development platform. Basically, that's their goal, to create that right level of abstraction for them. So I just want to give you an example. Maybe we are all familiar with this icon, right? This icon uh, represents a cloud uh, virtual machine called EC2 for AWS, right? So this is a typical EC2. It looks easy to provision, maybe 2 to 3 clicks from the AWS console. But to actually operationalize this, you need to consider a lot of things. You need to consider the tags. You need to consider how you will access the operating system. You need to consider how do you measure the metrics, how do you secure this, how do you do backups, how do you encrypt, how do you uh, have a layer of security in terms of network. So all of these things have a lot of complication just for a single virtual machine in the cloud. So with platform engineering, you create the right of level of abstraction to create this this easy to this infrastructure in best practices in the right abstraction that everyone needs, right? So for example, again, for a typical CI/CD pipeline, or for creating an infrastructure in the AWS with a CI/CD pipeline, it looks like straightforward, like GitLab. You use YAML, you code it using CloudFormation, right? YAML, CloudFormation, and deploy it to AWS. Typically, that's how we understand this and how easy we think it is. But when you actually look into it, when you try to operationalize it and do it every day, uh, and scale this, you actually repeatedly encounter these questions. How do you run our pipeline? How is our file structure? How do you structure projects? Do we need linters? How do we handle deployments? How to interface with AWS? How to monitor our resources? As you can see, there's a lot of things that you still need to consider just for a single pipeline. And there are a lot of technologies in terms of the CI/CD pipeline that you need to really look into, like what tools to integrate, what uh, workflows to do, is there an approval process. So the overall automation that you are doing is an engineering effort itself. And when you look into the perspective of how we actually work with the different kinds of engineers in our teams, like uh, typically in a cloud organization, and in a cloud uh, platform that you're interfacing. There are technical architects, cloud engineers, and platform engineers. No? So, of course, technical architects are the ones maintaining the design, deciding what kind of design they're trying to build, making sure it's highly available, redundant, all those important technical aspect. And they work with the platform engineers to design the right automation for the architecture. Cloud engineers, of course, operationalization of your infrastructure is really important. They work with technical architects to design the implementation, design and build the implementation. Then cloud engineers build and implement the right the and use the right level of automation developed by platform engineers to interface the cloud platform. So uh, a good thing to remind us, when we do platform engineering, we are interfacing the cloud platform. We're engineering on top of the platform that we are working on. So how do we actually do it? We create a product called internal development platform. We develop this specialized tool, specialized automation, specialized uh, uh, setup that on top of our infrastructure resources. It's really a layer on top of the tech of everything that we do. Whatever tools that you are using, you should create an internal developer platform to orchestrate those tools. And I know that we can all relate to this, that setting up these things takes a lot of time, and there's a lot of discipline designing all the best practices, designing all the standards within those tools. With platform engineering, you create the internal developer platform to create those best practices standards across all your practices. So in terms of the components of IDP, there are five things that we want to emphasize this evening: application configuration management, infrastructure orchestration, management, deployment management, and role-based access control. And I think we can all relate to this, that there are scenarios that we need to think about how do we actually configure our role-based authentication? How do we uh, change our automate or change our infrastructure in a dynamic and intelligent way, depending on the context, right? So uh, these things exist in an internal development platform. They automate, they create a layer of abstraction to those software engineering teams that uh, uh, who needs this, right? So I just want to read this and emphasize this to all of us this evening. Platform engineering done right means providing a golden path and paved roads that match the preferred abstraction level of the individual engineer who interacts with the ITP layer. So the keyword here is preferred abstraction. You create the right level of abstraction for your organization. So, is it DevOps? So, when we look into DevOps, right, in the early 90s, we have this paradigm called throw over the fence. Uh, the developers will develop the application, they will uh, they will ask the system administrators to actually run the applications on their behalf, right? And this cause a lot of friction, and the feedback loop is not happening faster. So DevOps with the uh, development of cloud technologies, of course started by AWS, enabled us to seamlessly integrate those dev and operations needs and concepts. So uh, from monolithic deployment, it became complex deployment. There are concepts right now of microservices or breaking down an application to different silo, to different services. So it it won't be a monolith that can affect or uh, can be a bottleneck of your application. So, and a lot of tools are emerging these days, right? And maybe it's a problem that we all face. What kind of tools that am I going to use? What next shiny CI/CD tool that we are going to implement? And the push for the DevOps culture is always there. That through DevOps, in terms of DevOps, you know that you are doing DevOps when you build it and you run it. And this is what it true DevOps is. So, but there's a problem. The issue with this approach, the true DevOps approach, is that for most companies, this is actually rather unrealistic. Most of the time, there is a cloud engineer or sysad. For others, they call it SRE, or for others, they call it platform engineer. So there's a lot of differences in terms of title, but most of the time, there are a different team who actually do the operationalization of our application. And it's really unrealistic to do the true DevOps in our midst, right? So while the you build it, you run in works for very advanced organization, it is very far from trivial to replicate true DevOps in practice for most other teams. So according to the State of DevOps Puppet Survey, 52.9% have a dedicated ops engineer. So only 3.1% claim, according to the survey, that they actually do to the true DevOps, the you build it, you run it DevOps. So basically, uh, some developers, like the 44%, or like the senior developers, they're doing DevOps tasks, and at the same time developing software or creating infrastructure or doing automation. So as you can see, there's really a challenge when it comes to implementing DevOps. And in terms of uh, i- the movement of adoption of platform engineering, uh, the use of internal platforms, uh, as you can see, uh, the more it's higher, the more it shows that uh, advanced organization actually uh, create internal developer platforms for their organization. So this is what best engineering organizations do. They set up platform teams who build IDPs, platform engineers whose focus is to create the right level of abstraction for them. So the point here, of course, not everything should be automated, not everything should be templated, depending on the organizational needs. So do others like messing around with Helm charts, or do do they like YAML, or others like Cloud Formation? Some other teams are doing Terraform. That's okay. And uh, depending on the engineering or the design that you're gonna do for your internal development platform, it's a way to agree on certain things on your organization. The goal again is to provide golden paths and pave roads. For example, adding environment variables and changing configurations. Maybe you have a fun story already in mind, of maybe a production issue because of a sudden change in configuration. How do you actually do rollbacks? How do you spin up a new environment? How do you enforce role-based authentication, right? So these things are a lot of things to consider when you're building in your application. And with platform engineering, rather than letting everybody operate everything and having to understand the entire tool chain to do so, platform engineers provide the glue to bind everything into a consistent self-service experience. This glue is the internal development platform, the internal platform. So because it's really, really hard to operationalize and scale uh, things. So the application team will interact with the internal development platform. The platform engineering team will create the internal development platform to orchestrate what is needed by the application team. Compute, network, storage, CI/CD, monitoring, and etc. From the words of Evan Butcher from ThoughtWorks, platforms are a foundation of self-service APIs, tool services, knowledge, support, which are arranged a compelling internal product. Autonomous delivery teams can make use of the platform to deliver product features at a higher pace with reduced coordination. As we come to an end, my emphasis this evening is that we treat our platform as a product to build the right level of abstraction. We engineer our platform. And with that, when we treat our platform as a product, we create the idea, we design, we prototype, we develop, we test, we release, we support, we maintain, and re-engineer. We develop it like, we treat it like our own uh, application, right? Our application or product that we continuously improve and re-engineer according to the needs of the users, which in this case are the applications team, because most of the time they're the ones consuming uh, our platform, right? So just to share with you some exciting uh, news as I end. Here at StatPoint we have different services and packages, and we have actually some promos that I want to share this evening. Like the Cloud Bedrock Landing Zone Foundation, it starts by $3,000. We do it for 1 to 4 Mondays. So basically, Cloud and Bedrock Landing Zone is a starter pack as your baseline best practices for your uh, environment, cloud environment. We also have a pilot and cloud migration starter pack wherein we help companies migrate to the cloud and assess what's needed to be done for you to maximize the potential in the cloud. And lastly, we also do POC and prototyping services for AI and ML and object recognition, and it starts with 20,000 for 2 to 3 months. These are sample packages that I want to share to you before I end. Of course, uh, as we wrap things out in terms of our team for SoftCon decoding AI, when we create AI applications, the key to scale it is and to have a platform for you to create those applications. We need to prepare our operational uh, operational infrastructure when we run these AI applications. So we need to plan out how our AI engineers will interact with the infrastructure where these AI services are running. So with that, I just want to thank everyone for taking time to talk, taking time to hear introduction to platform engineering. Thank you.
Thank you so much for the presentation, Sir Kevin.
Yes.
I am pretty sure a lot of people, well, there are already questions here. So let's address each question, Sir Kev.
Sure.
I'll start with the question from Randy, and that's what are the differences between platform engineering and site reliability engineering?
All right. So site reliability engineering focus on production reliability. Those who are running uh, instances or products or applications running already in production, or there are a lot of users using that product. So their goal is to maintain higher uptime. Their goal is to automate things so that the their cloud infrastructure won't be experiencing downtime, right? So from the word itself, site reliability. So their goal is to create to make sure their infrastructure is reliable. The difference is platform engineering, again, they create the baseline platform infrastructure wherein uh, application developers are interacting with.
So JC wants to expand that, and he's asking, what distinguishes developers from platform engineering on code repository and workflow, version management and development, and deployments rather? Does it differ from DevOps?
So I have seen platform engineering practices that they don't have a UI like what I've shared earlier. Like GoDaddy created a UI wherein they have uh, developers have a UI to click to self-service their application. I have seen implementation of platform engineering wherein everything is on YAML. So meaning they codify everything. You just need to add the specific parameters on this YAML file, then automatically it will create the necessary infrastructure for you. So the concept really is for platform engineering is to create that level of automation, again the right level of abstraction for you. So if if uh, if a code base or a code based automation or a CI/CD automation works for you already without requiring UI or GUI interface, that's okay. That's perfectly okay. And if it solves a lot of manual processes, then that's so you're doing platform engineering already.
Thank you, Sir Kevin. There's an interesting question from Brandito. How did you transition from zero to platform engineering, and what were your biggest challenges?
How did I transition from zero to platform engineering? So before I actually became a platform engineer or be in the cloud space, actually an application developer. So it's really important to get a grasp of how application are being developed. I've seen it in the industry. DevOps engineer or platform engineers are are at their best when they have ideas about software development, because you need to have a level of programming discipline in terms of platform engineering, so that you can automate a lot of things. So a lot of automation, you need a lot of logic, so you need a lot of uh, background in terms of programming.
Thank you. I hope, Brandita, he answered your question. There's another question from JC Maka. He's very active. Platform engineering will interface with data engineering and data science. How can platform engineers collaborate effectively with these teams to ensure that data driven insights and applications are well supported within the platform?
So how can platform engineers collaborate effectively? So uh, again, platform engineers create the right level of abstraction. They really need to work with the data science team or the data engineering team. They need to work together. They need uh, to treat the platform engineers need to treat the data science team, the data engineering team as their customers, so that they can create the right platform for them. So it's really a continuous collaboration between different teams.
Collaboration is the name of the game, is it? So there's a question from Mar de la Torre. Should developers be responsible for their own infrastructure and deployments as well? Or is it a bad practice?
Depending on DevOps is a culture, right? It's something that depending on the culture or the way you want to run your organization, uh, if they really want it when if they really want to push the you build it, you run it, definitely developers should be the ones running it. And uh, is it a bad practice? Is it a bad idea? Like what the service says in terms of what I've shared, right? Still, 55% of the people who are doing infrastructure work, there's a specific role. Only 3.1% is able to do the full DevOps paradigm right at the moment.
I hope that satisfied your question, Mar. All right, let's address the next one from John. How do you lessen the burden of the developers since in DevOps, the notion is you build it, you run it. They also sometimes they also have to maintain. So how
Yeah,
do you lessen the burden?
yeah. To lessen the burden, you need platform engineering, basically, because maintenance of those automation, those pipelines, those systems that you build to connect development and operations, it's a whole engineering effort itself. It's a whole discipline. It's a whole product development. So you need to rethink and think about what you would like to do in terms of those automation and treat it as a product itself.
Thank you. Lester is asking, do you view platform teams as the replacement to the traditional Unix or Wintel teams? Or do you think they're not necessarily mutually exclusive?
So yeah, I've seen organizations that part of their platform engineering team are experts of the Unix and the Wintel uh, setup. Definitely, they can still be in a platform engineering team. They're the SME subject matter experts on these areas, and they can provide the right level of abstraction for those who would like to interact with those systems. So, uh, again, platform engineering is creating the right level of abstraction for everyone in your organization. So uh, they can be quote unquote rebranded maybe to be platform engineers, definitely depending on the organizational direction.
There's a high voted, upvoted question here from JP Ignacio. What are your thoughts on the choice between developing an in-house IDP versus adopting open source solutions like Backstage.io? Can you share some pain points working with IDP?
All right. So yeah, it's really challenging to develop your own IDP. And in terms of Backstage, you need to adapt to their actual setup, right? Their actual paradigm, or how do they automate things? How do they actually orchestrate things, right? So the choice is uh, between customization or adoption to a certain tool, right? So uh, it's really painful to develop an IDP in terms of engineering. You need to really continuously develop your product or your platform until it's good enough to uh, solve a lot of the operational overheads that you're trying to to solve. And in terms of Backstage, there are skill issues or using other uh, pre-built IDPs. So there are skill issues. You need to learn also the way they wanted the abstraction that they're doing. So the pain point is for in that case is that you'll actually eventually be uh, be blocked to the point that you wanted to do certain customizations again, right? So you're gonna be uh, hitting some wall if you use a pre-made IDP. So the abstraction that you don't want, that you want, maybe you won't achieve it when you use those pre-built IDP. So uh, it's really weighing the cost between those two things, right? Uh, Building the customizations and automations that you need, or adapting to the pre-built uh, IDPs that are out there already.
We have another question. There's a lot of questions, Sir Kevin. Please don't get tired yet. So we
No
have a
worries.
question from Joanna. In tech organizations, when would having a dedicated DevOps engineer be more strategic or useful versus upskilling software engineers to apply DevOps practices?
When will have it? All right. All right. So upskilling certain individuals uh, to be DevOps, right? It really depends on the scaling issue. Uh, if the creation of automation is something that hinders your application team to actually uh, deploy your applications faster, then definitely you would want to someone to focus on the automation part of things. That's where you introduce platform engineers or DevOps engineers in your organization to focus on those automations for you.
Okay, thank you. Jojo, I thank you for your question. And here's the question, Sir Kevin, from Jojo. Should the platform team be involved and have an opinion with the architecture or system design direction of the software system built by the feature teams?
Definitely, yes. Platform engineers should understand what are the architecture strategy or holistic architecture strategy that you are gonna do in your organization. For example, in our organization StratPoint, we are heavily on serverless. So most of our engineers are serverless capable, and so with that, we'll create a platform that uh, will cater to serverless technologies instead of focusing on Kubernetes setups or Kubernetes orchestration.
Okay. All right. If there is an issue with the infra, should it be handled by the platform team or the application team? That's from John.
Issue in the infra. Definitely, it will be the platform team since uh, in a support escalation level, right? Depending on the flow. So if it's in the infra, so the next one who is interfacing with the infra will be the platform team. So it will be the platform team.
There you go, John. All right, we have the last question on the Q&A. If you have more questions, attendees, please don't be shy to drop your questions. So here's one from Ronaldo. Our DevOps team does most of the practices you mentioned. Should you say platform engineering is a new and improved DevOps?
Yes, I would agree that it's a new and improved DevOps, or it's uh, a, a movement or a culture that's currently gonna come more and more in the next coming years, because again, it's really hard to do through DevOps. You build it, you run it. So organization have will have to engineer those DevOps automation along the way.
Thank you so much, Sir Kevin. I hope that satisfied your question, Sir Ronaldo. Are there any other questions here, delegates? While we're waiting, may I request you for a very quick photo of Sir Kevin? I'll be turning my camera off and my microphone as well. Please smile for the picture.
Okay.
There you go. Going once, going twice. Do we have more questions here? There you go. I would like to read some of the compliments that was dropped in our chat box. Thanks, Kevin, says John Michael Javier of Stratpoint. I think he's your colleague. But there's also a comment from Cambridge, from Kate Germina, says, thank you, informative session. So there's also Erwin Andres of web capability of Stratpoint. Thanks, Sir Kevin. So thank you so much, Sir Kevin, for spending time and sharing your knowledge with everyone else. I guess that's it for this session. That's the last session for the day, and it
Thank
has
you so much.
been a great time learning along with you all. And I hope that I see you all tomorrow. Sir Kevin, thank you again very much for your time.
Thank you.
I'll see
And
you guys tomorrow.
thank you, everyone.